All right, so we're going to talk about today heights of presidents of the United States. And we have a chart here showing the heights of some of the presidents. We have George Washington here, who was pretty tall. We have Abraham Lincoln, who was very tall, especially with his hat. We have actually Franklin Roosevelt, who was pretty tall. A lot of people don't realize that because he was in a wheelchair. And then we have Donald Trump over here, the last person in the row. So what we're going to do are dot plots representing the heights of those presidents. So we're going to show you again how you can use this statistical data and these statistical representations to show real life stuff. So we're talking about here the 1st through the 22nd president, and here the 23rd through the 44th president. So we've divided it into two groups. And I'm going to show you how to find the mean and the median from a dot plot. First of all, what a dot plot means is these numbers here are the heights of the presidents in centimeters. So it starts at 162, goes to 194 in both groups. And this means that there's one president who was 163 centimeters tall. This means there were 4 presidents who were 173 centimeters tall, if that makes sense. So what we're going to do, the easiest to find is the median. And you guys got some practice in the last lesson finding medians of small groups of numbers. But here we know that because it's the first president through the 22nd, we know that we have 22 pieces of data. So if we have 22 pieces of data, if we're going to divide that in half, we're going to end up with the 11th spot. That's where our median is going to be because it's right in the middle. So let's count that, see where we get to. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, which means that our median would go right there. So our median is 178. Remember, if we have an even number of data, the median falls right between two pieces of two numbers. But in this case, both numbers are 178. So if we average the two numbers together, we'd still get 178. So that makes it easy on us. All right, let's find the median for the second group. So again, we had 22 pieces of data, which means we're looking for our 11th spot, 11th piece of data. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's right there. So that means in this case, our median goes right there. So our median for this group is going to be 182. Again, if these were two different numbers, we would have to take the average of the two of them since we have an even number of data, but they're both the same number. So our median is going to be 182. Now the mean is a little more, I'm not going to say complicated, it's just a little more involved because you have to add all the numbers together and of course divide by 22 because that's how many pieces of data you have. Well, you have one president at 163 here, one at 168, one at 170, one at 171, 4 at 173. So you kind of get the idea. That's how we're going to list them over here. I'm just going to make a column. 163, 168, 170, 171. Then there's 4 times 173, 4 of those, 174, 175. Then we have 2 at 178, 180. I'm going to go up here, but the next one, 4 183s. Then we had 1 185, 2 188s, a 189, and a 193. Now if you add all of these together, add them all, and divide by 22, because that's how many pieces of data we have, then you actually end up with 178. Now that doesn't always happen. As a matter of fact, it doesn't often happen that the median and the mean are the same. Most of the time they're very different numbers. The mean for this one, and I'm not going to list all the numbers, but if you add them all together and then you divide by 22, you actually get 181. Okay, so now we can compare these two groups of data that we have. All right, so the median height of the first 22 presidents is 178. The mean height is 183. Excuse me, it's 178 as well. It says a typical height for a president in the second group is about 182 centimeters. We found that out. So the question is, have U.S. presidents become taller over time? Well, if we look at our median and our mean, they're both less than our median and our mean here. So it might be difficult to tell from the dot plots, but I would say yes, that presidents have gotten taller over time because of our statistical data that we've gathered here. We have a proof using statistical data that presidents have gotten taller over time. Now the next question is, are the heights of the first 22 presidents more alike than the heights of the second 22 presidents? And it looks like to me they're more spread out here than here. But in the next video, I'm going to show you how you can find that from statistical data as well.
Okay, so this video is going to show you how to do mean absolute deviation. And we sometimes call that MAD. And you might get mad when you do it because it takes a little bit of time. It's a lot of calculation, but it's easy. It's very easy. All we're doing here in this table, I put all the values that are in our dot plot. There's 163, I put that there. 168, I put that there. 170, and then when there's more than one, for example, the 173s here, I put 4 of them. 1, 2, 3, 4, because we have 4. So that's all this is. And then we remember our mean is 178. Well, what we're putting in this column are the differences between the mean and this value. In other words, 178 minus 163 equals 15. So that's how we got that value. The 15 there, that's the 15 here. And we do that for each one. So we get 10, 8, 7, 5, 5. When we get down here to 178, there's no distance between the mean and the value, so we have 0. Going down here, didn't quite finish the chart, so for 188 minus 178 is 10, right? So we have 10 here, 11 here, and then 15 again here. Now, in order to get the mean absolute deviation, we add all of these together and we divide by 22 because that's how many pieces of data that we have. So again, we're going to add all of these together and then we divide by 22. You can do that on your own, but when you do that, you get that the mean absolute deviation is 6.45. And what that means is, on average, each piece of data is 6.45 centimeters away from the mean. Let me write that down. Each piece of data
is on average 6.45 centimeters away from the mean. Okay? Now, I'm not going to do the calculations for the second one. I did them on a separate sheet of paper. You can check it if you want. But when I did it, I got that the mean absolute deviation here was 4.27. All right, so the question we asked ourselves a moment ago was, are the heights of the first 22 presidents more alike than the heights of the second 22 presidents? Or maybe it was the other way around, but we can tell that the mean absolute deviation for this group is bigger than this group. So we know that the heights of these presidents are more alike than the heights of these presidents. So we can answer all of our questions now. We know that the median height of the first 22 presidents was 178 centimeters. Yeah, we said, yeah, that's true. We figured that out. The mean height of the first 22 presidents is about 183. I think we figured out that it was 181. A typical height for a president in the second group is about 182 centimeters. I believe that was the mean, or the median. So, yeah, we could say that that's true. U.S. presidents have become taller over time. We compared our means. And when we compared the means, we found that 178 is less than 182, or 181. So, yes, the presidents have become taller over time. And then we just compared our mean absolute deviation here to find that the heights of the first 22 presidents are less alike than the heights of the second 22 presidents. So this one we said was not true. Okay, here it asks us specifically, the MAD of the second data is greater than the MAD of the first set. So the MAD of the second data we said was 4.27. And we said the MAD of the first set was 6.75. So is that true? Is this greater than that? No. So this one was not true either. Okay, this will help you with the assignment for today. We're using mean and median to answer questions based on dot plots. I think there's one histogram in there, and choosing between the two. So here's an example. This might help you out once you do the assignment. We're asked here, we have a dot plot here that shows the ages of 20 people at an 8-year-old's birthday party. And the mean is 15 years old. If we add all these together and divide by the number of people we had, we get 15. The median, when we count and find what the center of the data is, it's 8 years old. Well, the reason we have such a huge spread here on the data is because we had the kids and then we had the parents. So the question is, was a typical person at the party 15 years old? Well, there were no 15-year-olds there. So in this case, it might be better for us to use the median to describe our data, because the median was 8. The median said 8 years old. Well, yeah, a typical person at the party was around 8 years old. The mean is misleading. Okay? In this case, over here, when we're talking about dogs being treated at an animal hospital, our mean was about 7.8 years old and our median was about 8 years old. Well, they're very similar. So the question is, was a typical dog at the hospital 8 years old? Well, yeah, a typical dog was 8 years old. Our mean is 7.8. That's almost 8. Our median is 8 years old. And look at how many 8-year-old dogs we have here. That's our mode. We have 1, 2, 3, 4, 5 8-year-old dogs. So a typical dog at the hospital was 8 years old. Now we had a lot of variation here. We had different ages. But we could say that this is true, and in this case, we could really use the mean or the median, either one. And we could say, yes, a typical dog at the hospital was 8 years old. All right. Hopefully that helps with your assignment for today, and I will put a summary video up, but that's all for today.